Welcome back, everyone. In the previous video, I ended up talking about the noble gases or the inert gases. And I mentioned that all the inert gases, such as helium, neon, and argon, all have full shells. So helium has the 2, neon has the 8, and so on. We refer to them as inert gases, meaning that they do not react with any other element in the periodic table. And the reason being that they do not react with any other element is because they have full valence shells. So the key to inert gases is that they have full valence, remember, the outermost shells. So that is the key to understanding reactivity of elements. If they have full valence shells, they do not react with anything else. All other elements in the periodic table other than the inert gases do not have full valence shells in their atomic state. And that is why they react with other elements. Their goal is to achieve a full valence shell. So let us look at some of the elements that do react and talk about how do they achieve that full valence shell state. So let's look at lithium, one of our wonderful metals. Lithium has an atomic number of 3, which means it has 3 protons. Remember, all atoms in the periodic table have a 0 charge. So the lithium atom has a 0 charge, which means it also has 3 electrons. Lithium is in which group? Group 1, which means how many valence electrons does lithium have? 1. So if we draw lithium as a Lewis dot, lithium has 1 valence electron. Now, you may think, well, oof, that means lithium has to gain 7 electrons? How's it going to do that? That is not the case, and let me show you why. Let's draw the Bohr-Rutherford for lithium, and that's going to make a lot more sense. The atomic weight of lithium is 7. So we've done lithium in a previous video, so I'm just going to sort of speed through this a little bit more. So we have 3 protons, we're going to have 4 neutrons, and we have 3 electrons. So the first shell is going to have 2, and that's the maximum it can hold. The second shell is going to have 1, because we have a total of 3 electrons. Now look at it. In order to achieve a full shell, lithium actually has 2 choices. It can gain 7 more electrons to add to shell number 2, or what's actually the easier option is to lose this 1 electron up here. Because look what happens if lithium decides to give up that 1 valence electron. It now has a full shell. Because remember, shell number 1 can only hold 2 electrons. So by giving up its valence electron, lithium actually achieves the ideal state of a full valence shell. So what lithium is going to do is lose an electron. And it's going to lose this one. So let's say I now draw the Lewis dot without this 1 electron. So it's going to choose to lose the 1 electron, not gain 7, because that's not going to work. But if I lose an electron, am I still going to have a 0 charge? Well, look at it now. I still have 3 protons. But do I still have 3 electrons? Not anymore, because I lost 1. I now have 2 electrons. So what's the total charge now? It is +1, which is why we now have to draw it as +1. We can't just write lithium. we have to depict that now lithium has a +1 charge. And it's no longer called an atom, because an atom has a 0 charge. It is now referred to as an ion, because it has a charge. And specifically, ions with a positive charge, +1, +2, ions with a positive charge are called cations. So if you have an ion with a positive charge, it is referred to as a cation. Lithium is all happy now. It's achieved what it's wanted. It has a full shell and a +1 charge. But that's not always the case. Not always losing. There are some elements where gaining electrons may be the solution to their problem. And to do that, let us look at carbon. So look in your periodic tables and let's look for carbon. It is in group 4. And it has 6 protons, 6 electrons. And because it's in group 4, 1, 2, 3, 4 valence electrons in our Lewis dot diagram. So in this case, carbon, 6, sorry. See, even I can make a mistake. 6 electrons, that makes a lot more sense. So carbon now has a choice just like lithium did. Carbon can either lose all its 6 electrons or gain 2 electrons in order to achieve a full valence shell. If you had a choice, would you lose 6 or gain 2? Most of the time, you're going to gain 2 electrons. So carbon, to achieve its happy state of full valence shell, will now have 1, 2, 3, 4, 5, 6, 7, 8, because it's gaining 2. Now carbon's all happy. It has its full shell. But 0 charge? I don't think so. We had 6 protons, but now we have, if we're adding 2 electrons to our deal, we now have 8 electrons, leading us to a -2 charge. So carbon, in this case, is going to have a -2 charge. And just like lithium, it is now called an ion. And because it has a negative charge, we refer to it as an anion. If it had a positive charge like lithium, it's a cation. If it was a negative charge like carbon, it is referred to as an anion. So that is how elements decide whether they're going to gain or lose. It is in order to achieve a full valence shell. And some will decide to gain, some will decide to lose, depending on their structure initially. Patterns. Once again in the periodic table, you will notice that all elements in a group have the same number of valence electrons. In other words, they will all have the same ionic charge. And that's what I'm referring to as the -2. So all elements in lithium's group, which is referring to, in this case, hydrogen, lithium, sodium, potassium, they're all in group 1. So they have a +1 charge. All the elements in group 2 have 2 valence electrons. They will lose 2 electrons and therefore have a +2 charge. So all elements in the same group have the same ionic charge. Of course, other than group 8, which are the inert gases, they don't gain or lose. They stay with a 0 charge. I hope this has helped make sense to how elements react, and in the next video, we're going to start talking about the reaction between elements in the periodic table.